Good morning, all of you. Welcome back to graphic session. Today, let us discuss about two-dimensional geometric basic transformations. And our agenda today includes, translation, rotation, and scaling. As you all know, what is translation? Keeping an object from one place to another place, either horizontal direction or in the vertical direction. So when you are displacing the amount of distance, you are representing the distance by translation coordinate. That is, in x direction x and y direction is y. So the new coordinate will be changed to x dash is equal to x plus tx and y dash is equal to y plus dy. So the translation vector or shift vector t is equal to t of x comma t of y. Whenever whole body is concerned, it moves object without deformation. So given you the pictorial representation that from one point to another point, the point is having x and y coordinate, the new point will become x dash and y dash. Similarly, for the whole body transformation, an object is having a lot of coordinates. Each and every coordinate will be translated to a new area. That coordinate is also be changed like this kind of translation. Okay. And similarly for rotation, it's a kind of angular displacement. It is associating an angle for the movement of object is concerned. A coordinate is rotated to a new direction having new values. So that is represented by matrix. That is, as you know that a circle equation r cos theta minus r sin theta. The angle of displacement from the initial coordinate theta to a new value will be pi will be added. We will get a formula cos a plus b. That formula will be used here, r cos pi cos theta minus r sin theta r sin pi. Similarly for the y coordinate also, y dash is equal to r sin pi plus theta is equal to r cos pi sin theta plus r sin pi cos theta. So when you see the original picture is p of x comma y, will be rotated to new point is called p dash, having angle of displacement is theta. The original angle is pi, so that the pi plus theta will be added, and we are getting a new values, and the new values are posted as a matrix that is equal to cos theta minus sin theta and cos theta. And the rotation based on the pivot point, not on the origin point some other on the first quadrant, the second quadrant, third quadrant, fourth quadrant. Let us take the first quadrant. The point is not in the origin. If it is on some other point, that is called pivot point, having different equations. The equations are x dash equal to xr plus x minus xr. The distance will be subtracted, and we use the angle of displacement. Then we arrive a new formula. So this is to be pictorially represented in the graph also. And we have another transformation called scaling. A kind of object will be transformed to a bigger one or a smaller one. We have to change the coordinate by x value or by y value. So when we are multiplying with the displacement value, the coordinate will be changed. Either the picture will be having uniform directions x, y in a square format. When you want to make a rectangle, we have to double it by x direction or double it by y direction. Means the entire picture is changed 2 times bigger, or 2 times bigger in x direction, or 2 times bigger in y direction. So that could be represented by mentioning the coordinate sx and sy. Will be multiplied properly by the coordinate. We will get a new coordinate x dash y dash equal to sx0 and 0 is y, and we get a new point p dash is equal to scaling factor into the previous matrix. Okay. Here we are doubling the x direction, so that the square will be transformed to a vector called a rectangle. Okay, fine. And these are the basic transformations. And similarly for rotation, scaling also can be done by using a fixed point, not on origin point, a fixed point. So that point also will be taken into consideration. That displacement is subtracted and multiplied by the scaling factor. We will get a new equations. So these are the basic transformations for the two-dimensional geometric graphics is concerned. So that's for today's class. Bye.